Alright guys, got another video for you. This one's a little different than just, straight up high voltage. But this is in the same realm as, high current. So, little cap bank that was here, plus big box full of capacitors. Gotta have a way of driving that. So, this is the overly complicated way I decided to do it. As always, we have a 1 gallon air tank right here. That comes with a regular air fitting coming in, valve to close on and off. Manual gauge that is bent at the top because it decided to fall on it, so it only reads up to about only reads about 75 psi before it gets stopped. Gotta see if I can fix it at some point. Then you have a electronic psi gauge, which that's what I'll use for mainly reading, because this will go back to the remote control box I will be using with a digital display, probably an Arduino running it, because I mapped out the actual psi curves. I have a notebook that actually has it, so if I come on over here, this is the rough data curve. So if anybody actually wants to take a look at that, with that one, and I can even leave a link to it if people want to know, I can let you know, but all it is a 0 to 280 psi pressure gauge. I even think this is the box for it. No, it doesn't say anything. Oh well. But then that will tell me what the PSI is in the tank. Then there's a manual readout so I can see. Then you have your airline coming out. Plug is in the back side. Airline comes out to a, a 4-way 2-position valve block. Then that comes out to this cute little linear piston. So still a little bit of pressure on the system. So I can't really pull it with one hand. I can do it with two though. But that's just a little linear guided. So this will sit with probably a block of Delrin or probably just a plastic cutting board because it'll work just fine. And that'll sit on top either side to connect to the actual main bus bars. Now you may be wondering what I'm going to use for a bus bar. Well, let me pull it out. Set it down. This is the bus bar. This is 1/4 inch by 1.25 inch copper bar, 36 inches long. Weighs, a good hefty amount. And there's a fly that just keeps attacking me. This is what's going to actually be part of the main contacts. So the main contacts themselves are going to be overrated for current handling capability, even though it's going to be pulse current. I'll probably build removable contacts on it so I can swap them out whenever I burn through them, because I know I will. But that will go into that will sit over here. So there'll basically be a bar and a bar either side driving up into the contacts, because if you know anything about pneumatics, your most force comes from pushing, because you got to think about the fact that there's a plunger here. You have more surface area pushing compared to pushing down, because then you have the rod in the way. So you get more speed, more force pushing than actually pulling. That is just the standard way pneumatics work. There's even already threaded holes and then regular just through holes if you want to do it. So that's what I'm going to be using. It'll be pretty simple. I've got two 24-volt DC relays to drive everything with a 24-volt DC mean well power supply. So the power supply will power the relays and then drive that'll be for that. So one relay will be for the shunt resistor. It's a short resistor. So whenever you're done firing and throw it in the safe, this will put a short resistor across it, which I've got a lot of them laying around. And this one will be for firing the solenoid. If I even need it, I may not even worry about it. But I have two relays, so if I want them, I got them. But to give you a little bit of proof of how great this works, I got 24 volts loaded up on the power supply, and I do apologize for the absolutely messy workbench. It's kind of cleaned up since it was, but this project's been ongoing, and I just keep throwing all the stuff on it. So what we'll do is I'll throw about 25 psi on the tank, and if I were to touch this wire to here, put you guys on there. You can see it works. Now to give you a reference how much force this has, I'll load it up with a measly, go right back up to about a little over 25. I'm going to throw this 35 amp hour battery on it, which weighs probably every bit of about 10 or so pounds. And watch what happens with 10 pounds sitting on it. Oop. Drives it like it's nothing. So now I gotta hold the air tank because this thing is throwing so much force that it's throwing everything off my bench. But it's shoving around 10 pounds like it's nothing at only 25 psi, and this will probably be ran all the way up to 100 psi. Jeez, everything's falling off the bench. Stupid thing has too much power. But yeah, so and you can see it only diminished a little bit of the pressure in the tank, just a couple throws. So the reason why I'm doing an air tank is so there's an on-site reserve to get the most amount of volume and pressure, because your airline will diminish the amount of actual force you can have. If I did that off of this actual hose, you would see a lot more of a reduced force that you could have. Just because basically an airline, I guess you could say, works similar to an inductor and a choke. So that will actually choke the amount of force you can have, because unlike water, air is squishy and it will compress itself and then have an actual air hammer effect basically. When that tries to slam, it may actually bounce a little because there's enough of an actual air in the system where it can bounce. So by doing a short tank with a short pieces of hose right there, this will probably all be the exact same length of hose, and I will mount it as short as possible. And that way I can get as much force as possible, as fast as possible. So, and then when I do the contacts to drive up into the plate, I'll probably build springs underneath of it probably do some sort of mounting system with springs, so that way it can actually flex a little. But that's the current thing that I am working on. I am hoping to get it done soon, so that way it can be done. But it's an expensive project, so this one will probably take a few months to actually be able to finish, because it's expensive. The bus bars especially are expensive. That one bus bar was 100 and not 100. It was basically 100. It was 90 bucks. So for that one piece of copper. Anyways, thank you guys for watching, and I hope you guys will enjoy this project as much as I do, because throwing a couple thousand amps through something random and seeing how well it holds up is always a lot of fun. So anyways, thank you guys for watching, and I'll catch you on the next one.